In calculating the trig integral, if you have the integral of sine x dx or sine u in general, so let me write down sine u du, it is basically negative cosine u plus constant of integration. The integral of cosine u du is sine u plus constant of integration. If I ask you to calculate the integral of tangent u du, it becomes ln of absolute value. You have a negative sign as well in front of it, so let me just put the negative sign here. ln of absolute value of cosine u plus constant of integration. And when you're calculating the integral of cotangent of u du, it is nothing but the ln of absolute value of sine u plus constant of integration. The integral of secant of u du has formula ln of secant plus tangent, ln of secant of u plus tangent of u plus constant of integration, assume this is positive. And when it comes to the integral of secant squared, it is tangent of x, secant squared of u du, it is equal to tangent of x or tangent of u. We're using everything in terms of u. Tangent of u plus c, and the integral of cosecant squared of u du is nothing but negative cotangent of u plus c. So these are the basics of integral when it comes to trig functions. Later on, we're going to talk about hyperbolic sine, hyperbolic cosine, and other types of integrals involving the trig functions. If you have the integral of secant tangent, you have the multiplication, the integral of secant u times tangent u du. This guy is equal to secant u plus c, and these are popular or famous trig integrals. The integral of cosecant u cotangent u du is equal to minus cosecant u plus constant of integration. And as you remember, secant of theta is equal to 1 over cosine theta, and cosecant of theta is 1 over sine theta. These are what you learned in pre-calculus. Then these are the antiderivatives. You can basically take the derivative of right-hand side and show that it's equal to the quantity inside your integral. We're going to use these shortcuts to calculate some definite and indefinite integrals. For example, suppose I ask you to find the integral of 2x plus secant x tangent x times tangent x dx. So you can separate this integral into the summation of two integrals. The first integral is the integral of 2x dx plus the integral of secant x tangent x dx. To calculate the first integral, we have to apply the power rule, which was, if you have the integral of u to power n du, it is u to power n plus 1 over n plus 1 plus c. So the first integral can be written as 2x squared divided by 2 And the second integral is the integral of secant tangent that you already know how to deal with. This is this integral here. It is secant u, which in this case, u is x. So just copy this guy down, plus secant x plus constant of integration. And you can simplify this to x squared plus secant of x plus c. Another example for you. Suppose we're interested in calculating the definite integral of cosecant of x times cotangent of x dx as x bounded between pi over 3 to pi over 2. Well, do you remember the integral of cosecant times cotangent? As you remember, this integral is equal to negative cosecant of x plus c. But since we have a definite integral, we just need to apply the fundamental theorem of calculus. As x ranges between pi over 3 to pi over 2. But again, remember the definition of cosecant. Cosecant of x or cosecant of theta is 1 over sine x or sine theta. If it's easier for you to remember it that way, you can rewrite this guy as well. So this can be written as negative 1 divided by sine x, as x is bounded between pi over 3 to pi over 2. So let us do the substitution. This guy becomes negative. You can leave the negative outside. 1 divided by sine of pi over 2, which is 1, minus 1 divided by sine of pi over 3, which is square root of 3 divided by 2. So this integral is negative 1 divided by 1 minus 1 over square root of 3 divided by 2. Or, as you remember, you can write this in rational form as well. You can rationalize this later. So this guy is minus 1 minus 2 divided by square root of 3. Or if you distribute the negative sign, you get 2 over square root of 3 minus 1. You can leave it as it is. But remember that you can always rationalize this as well. To rationalize this, you can take the common denominator and then multiply by the conjugate. So if you take the common denominator, square root of 3, or you can just multiply this by square root of 3 and square root of 3 to rationalize the first fraction, it doesn't change any final answer. So you have 2 times square root of 3 divided by 3 minus 1, or the final answer can be written as 2 times square root of 3 minus 3 divided by 3. So you can leave it like this, or you can take the common denominator at the end and write it as 2 square root of 3 minus 3 divided by 3. And again, remember that sine of pi over 3 is square root of 3 divided by 2, which is the same as cosine of pi over 6. Those of you who want to refresh your memory about pre-calculus and unit circle, this is what we had before.